Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in geometry part A. This is lesson 10, and we're going to talk about the angle bisectors and end center of a triangle. So let's take a look at what we have to do. Remember, all this information is covered in the lesson content as well. So please take notes and then compare how we explain it in words with how we explain it verbally. So let's take a look at some of the properties of an angle bisector and a triangle. First thing is, since it's an angle bisector, it will cut every angle in half. So we'll have 3 angle bisectors. Each angle will be cut in half. And we don't have to do all 3. We can just do one. And since we're talking about the end center as well, we're talking about what happens when we do all 3 at one time. The bisectors are concurrent at a single point, and that single point is called the end center. And the end center is equidistant to the sides of the triangle. So let's take a look at how this will look. So here is a triangle. You see that we've got our bisectors right here, these rays that are drawn in red. These are the angle bisectors. You see all 3 of those do intersect at one point right here, point D. And then point D, from point D to the sides, we've got these perpendicular segments right here. Those segments will be the same length, so they will be congruent to each other. And then here's another example. This is an obtuse triangle, same thing. You see we got the angle bisectors in red. They intersect at this one point W. And then we've got these perpendicular segments in blue right here, and those segments will be congruent to each other. The end center is the center of a circle as well. So we could take a compass, place that compass right here with the tip, and then a point on one of these 3 segments right here. And that circle we could draw inside the triangle. So we can draw a circle that will touch those 3 points right inside the triangle. Same thing over here. That would be the center, and these 3 blue segments, those would be radius. And those we could take and we could put a point here and draw a circle that goes all the way around. And that's called an inscribed circle versus the perpendicular bisectors, which is a circumscribed. Circle means around, and an inscribed means inside. So circumscribed versus inscribed. And as the name implies, the end center, so these segments will always intersect somewhere inside the triangle, and that makes sense because we are cutting each angle in half. So let's take a look at what we're going to have to be able to do with the end center and with the angle bisectors. So we're going to name some congruent parts here. So here is our triangle, and we're going to name segments that are congruent. We're going to kind of assume that D is the end center. So what things can we kind of say are congruent based on that being the end center? So, one thing that we can state is that these 2 angles right here, these 2 angles are going to be congruent. So we can state that. Angle BAD, so angle BAD right here, and not G, because G is a different point, but D right here. So that angle right there is congruent to this angle right here. And so what else can we say? We know these 2 angles are congruent. So that's angle ABD and angle CBD. Those 2 angles are congruent. Same reason. That's an angle bisector. We know that this angle is going to be congruent as well. So that's BCD and ACD. Those 2 angles are going to be congruent. I wrote the other way, ACD and BCD. We also know that those segments that go out at right angles, those are also congruent because it's equidistant to the end center. So we can say that a segment ED is congruent to segment FD, which is congruent to segment GD. So using that, let's find some measures. So here's my triangle. So based on what I'm given with these numbers, what things can I say? So for example, what's the measure of angle DBC? So DBC. Well, since these two angles are congruent right here, I don't know if this angle's 35. Well, guess what? This one's going to be 35. Okay, what about angle ABC? So ABC, that's the full angle. Well, the full angle, since this is a bisector, these two angles would have to add together. That's one of our angle addition postulates that we talked about. The 35 plus 35 is 70. All right, what about ACD? So ACD right here. Well, same thing, since these two angles are going to be congruent, and since this angle is 30.5, well, guess what? This angle is also going to be 30.5. What about the big angle, ACB? Again, angle addition postulate, we're going to add those two angles together, and they're going to equal 61 degrees. What about BAC? So angle BAC, so that big angle. Well, what are we going to do there? Well, this is a triangle, right? We've talked about triangles for a few lessons now. The sum of all the angles in a triangle is 180 degrees. So what are we going to do? We're going to take 180. We're going to subtract the sum of the other two angles, which is 70 and 61. So 70 plus 61 is 131. So that means that this big angle right here is going to be 49 degrees. Well, then how do we figure out BAD? Well, remember that this is a angle bisector. That means BAD will also equal CAD, and it's going to equal half of 49, which is 24.5 degrees. So each one of these angles right here is 24.5 degrees. So you don't have to be given all the information to figure out something, because we can use stuff from previous lessons to figure this out. And what about segment FD? Well, segment FD will have the same length as segment GD. Remember, these segments are congruent. And it's also congruent to segment ED. That means all three of those angles or segments will be 16 degrees. And now how is this going to look when we start to do some problem solving? Well, here's our picture here. So we're going to solve for X and Y using stuff we know about angles bisectors. Let's start with X. Let's solve for X first. Well, X involves the incenter and the segments congruent to the sides. So that means this segment will have to equal this segment. So the length XW will have to equal the length ZW. And so we're going to substitute what we know. So we know 3x minus 5 equals 2x plus 15. Now we're going to solve the equation. We're going to get the variables on one side. And that gives us x minus 5 equals 15. And we're going to move the variable or the number to the other side. So that means x is going to equal 20, solving a multi-step equation. Well, what about the angle? Well, remember the angle bisector. This is an angle bisector. So that means these two angles are congruent. So we're going to say that the measure of angle PRW is going to equal the measure of QRW. So we're going to substitute and let those equal each other. And we're going to solve the equation. We're going to subtract 4 from each side. That's going to give us 2y equals 8. And we're going to divide by 2 to give us y equals 4. So I hope this helps you with the angle bisectors in lesson 10. If you still struggle with this content, please let us know in a teacher message or make an appointment for a help session.